So hi everybody and welcome back to the C++ tutorial series for absolute beginners. This is video 207 and in this video we continue with our exercise. In our last video we talked about the bubble sort and we talked about this website here who presented a code for bubble sort, but this code was not a bubble sort. We figured this out, but the description was right. So our training was good that we trained to learn code reading, and in this video I want to continue with code reading, and I told you that you should try to figure out this QuickSort. And again we tried reading the code first, but here we have a problem. If you try to copy this code here and paste it here and then save and run it, then you will realize this code is not even implemented right. And you can see we have here a variable which is not defined right, and probably there are more problems. So instead we skip this QuickSort on this website and search another QuickSort on another website, and I choose this site this time. This site is Geek for Geeks. And here we have Geek Week 2022, and we try to use their QuickSort implementation. Again, we copy the code, try to understand it, and then we read the implementation and see what we understand about this implementation, right? So I copy this one, again I paste it in, I save it, I test if this code is running, and we see yes, it is running, nice, and it is ordered here. Yes, the numbers are ordered. Let's see. So we have to Control M and see what we have here, and you can see it starts with a comment which says this is our implementation of QuickSort algorithm, okay, and then it starts with including the IO stream for our say out and so, okay, this we know. Here they're using again namespaces. Today when you see this line of code, you know this is probably a demonstration code for beginners, because they use most time this line of code. All right, but we use not this one. We know why, because it could cause problems in certain scenarios. And then we have here two functions, and the main function is our start function where we will start later, and we have two additional functions which are one is QuickSort and one is called partition, and we will see what this is. All right, let's try to analyze this code fast, and again I will use Paint. Let me open up this Paint here and for demonstration purposes, and let me change here this code before we start, because you can see this array is long and QuickSort is very complicated, and I want not explain it in full length because that takes too much time. Instead I try to make 3 iterations, so and not 3 iterations, I try to explain 3 elements. It will be more than 3 iterations to sort them, but we changed this here a little bit, and let's make this one also shorter. All right, with that we can test this again if this is sorting, and we can see no problem so far, and it's indeed 349, so the values are okay too. All right, let's try to explain this one, and for this purpose that's why I make now a short array. That was good that I shortened this one. So now a short array, let's make you 1, 2 and 3. This is my array. This okay, Control Z this one. Let's make this array a little bit more down, this one so. And then I write fast the numbers in. And you can see we have here 934. And I write the slots too, because slots are very important. We start an array with slot 0, 1, 2, and we call this an array. And the name of this array is R, right? And this is our array. All right, let's copy this one because I need this later probably again. Let's copy and paste it, and I will use this later again probably. So let's put it here later for later use. All right, with that said, we can start to analyze this code and see what we understand about this code, or what this code is doing, right? So first of all, we start with main, of course, because this is the start point of the program. And here's the first thing: we create an array. Interesting is here this array has no number, and if it has no number, it must need this initialized list. We know this, right? If you use no number, the compiler needs this initialized list with the curly braces. It calculates the elements on its own. All right, with this set, this line we have here as an illustration, we have this name RR. Then we create here Rn. This n, when you read it the first time, it is absolute no idea. And if it's also very bad named, for example, in projects, don't use bad naming. You see, I have no clue what this n is. Of course, I know that this n is here related to this one because I watched it already. But when I read this first time, no clue what n is. And when I click on this n, you see it's highlighted here. It is used in these places, but how the hell I know that this one is related to this value here? All right, bad naming, no documentation, no clue what this is. All right, let's continue a little bit and see what we have here. Here is the word function, a quicksort. That sounds very nice because we want to make a quicksort and it's calling the function here on top. Okay, and this quicksort has here values. It needs an argument of rr, which is our array. Okay, then it takes here and to see what arguments it takes, we have to read the syntax here. And it says, okay, we need an array which is of integers. We need an integer for the start here and integer for end, which means which we get from here. And we can write these values here so that we have that. So what we have here is this array is clear. This is all times array. I skip this and just write the other two values. The one is the start value, which is 0. And the second one is end. N is 3. 3 minus 1 is 2. All right, we have these values, and these values are called here on our quick function. And I write these values here as well so that we can see all time what input we have. These are the arguments which we use. And let's go into this quicksort and see what the quicksort is doing, because this should sort our thing. So first of all, we see here base case. This argument, I have no clue what it's meaning, but I know what this is. This is a if. We know we have a condition. But interesting is, look, this if. This is the short version of a if, right? Normally we have here curly braces, but in this case we have no curly braces. And I hope you remember why we have no curly braces, because like I said, it's a short version. And the short version works only if you have here one statement, one line statement. If you have here a little bit more, like a else, then this works not, then you need the curly braces again for the scope. All right, this works, so but this will work. So let's see what this if doing. This if here checks the condition is it takes here the start. Let's write this one here. Start is our 0 greater equal to what? To end, to 2. So it checks if this one is true, and then if it's true it will enter. So this one will be not true, so it will not enter at start. But let's go and see what happens if it's true. If it's true, we have here return. Careful, this return is not a function return type. What I mean with this, normally when you have here a void, I mean, if you have not a void, for example, you have here a type and you use a return value in a function, you return the type here, a value for this type here. But in this case, this return, it has another meaning. What is the meaning in this case? In this case, it means it is interrupting the flow of this function, because it says here, stop here, and don't execute the other code here if this statement is true. But at start, it's not true. But if it's true, interrupt. So this is the meaning. So this comment I don't understand, but I understand interrupt. That's more meaningful. All right, let's go to the next part. Here it says partitioning the array. Of course, you need to know what partitioning means. I don't know. Let's see what happens. So let's see. We are creating again a variable which is called p. Very bad naming. I don't know. It's just a p, which is a number. More node. And then this p get assigned a value, but this assignment comes through a function call with, which means when you see something like that, that needs a return value. So this partition function we can see here on top has a return value int. All right, and now we have to figure out what this p is and how this p get its value from this partition. So we have to go into this one, but before we go on, let's write here the arguments again. So as our array, we know this start and end. Start was 0 and end was 2. All right, that was our values which we get from here down, right? That was here. It's still the same. We have nothing changed. All right, and with that we can go to the partition part. Let's open this one up and write the values here as well, 0 and 2. And the reason why I write this can be changed later. And that's why this is step 1. All right, let's go into, and now I have here creating some values, and while I'm creating these values, I will also write these values here on my partition, yes, on my screen here. And probably I need the other ones too. I forgot them, I should write them too, which means I need here the value start. Where is that? Yeah, start and end as well. All right, let's write them fast here because we probably need them. Or perhaps not. Let's see. Oops. Let me do this again. So, and write this one here. All right, let's start here. Start was 0. All right. End was, what was end? 1, 2, 2. And what we have here, int pivot. Pivot is what? So we are creating the variable pivot, and pivot is here. Now we have to get it. You see, when you see something like this means go to the array and find the slot, which is the start indicating here. The start says slot, the start is our 0. We can see it. Go to the array, look to slot 0, which is here, and get the value. All right, this means 9, right? We check this, we get the value. Okay, 9. That was this one. Let's continue here a little bit. We create a count. I don't know what count is, but the name count is indicating that we are counting. This naming is better than all other things, I think. So count, we will probably count something, is 0. Okay, then we go here to this next line, and this is just a loop again. We know what means loop. We are looping through something, an array, or we are just trying to count something. We will see, but let's see what we have here. This loop here, it says it creates a new variable, and the variable starts with start plus 1. Start is 0 and plus 1 is 1. So we have here again a little bit bad style. I'd like the other style here, so I can write here more comments. That's good. And here, so we can here write the input. So we start with what was this, 1, and then we have the I is 1 and range is 1 to end. End is our view, so we have here less equal to 2, something like that, and the other is just the increment. The increment we don't need. This one is okay. This is just this one what we need. All right, with that, let's see what we have here. So this loop will loop here 2 times. We can see start 1, 1 and then to 2, right? When it's incrementing. So it's incrementing 2 times. We have again a short if, and this if is doing what? And when the condition is true, we will count, increase this created count here. Interesting. And this created count will increase only when this condition is true. Let's check this condition here. Let's write here the condition first. It says here I is here. We can see this I here, careful, is calculated. It's 1, not 0, because start plus 1 was it. So okay, I go here in my array. I go to slot 1. Very important is here. Slot 1 is here, which means is the value 3, and I compare it with my pivot. So here I compare this one with my pivot. Let's do this with a color. Let's say something like so. Oh, not so. Let's make this. So this is this one, and I compare it with pivot. Pivot is 9, right? So I compare this value with this one. All right, and we make a less equal comparison. So this one start value, this one end value, and less equal. And this one is true in this case, right? So let's make this. This is true because 3 is less than 9. And I increment this one. You can see we have an increment here. So I will test this one. I will test this one. And if this one is also true, and that will be also true, by the way, because 4 is again less than 9, because we have here again less equal. So we have here count. This count here was at start set on 0, but after this one in this for loop, it becomes 2. We counted 2 because 2 times true, and that was it. More I don't know about this one. So till now, what can I say till now? I have no clue. I just assign values. That is the thing what I can see. I don't see anything that we are sorting. We are just assigning values. That's it. Let's continue. Perhaps it gets better in future. So let's go to the next side. So it says here we are going here in, and it says here given pivot element its correct position. So this pivot here we have a pivot, yes, here on top. And we are changing this probably. Let's see how, let's read the code. That was just the description. Now we read the code. Let's make here space. So the pivot index, we are creating a new variable. Let's create this new variable first. It says here pivot index. Oops, wrong color. Let's make this one fast. Pivot index. All right, we have a pivot index, and this pivot index is counted how? With start plus count. Start is 0, count is 2. Careful, that was first, now it's 2. So the best way is we are doing what? First of all, let's write the number here, 2. Oh, wrong color again, of course. Let's write it here, 2. And here we are deleting the first one because this one is overwritten. So let's delete this one. That was just the start value. All time when you see that I deleted something means it was first created and then changed. All right, this is changed to 2. And pivot index here is calculated to 2. Let's continue. And now interesting, we have here another function, but we have here a problem. This function here was not here in our start list, right? So our start list has only 2 functions, which called partition and quicksort, and then main. Where is this function here, which we are talking now, which is called swap? And that's a problem because they are using a std library, and how you can see this, you hover your mouse over it and you have to read this tooltip. And when you read this tooltip, you can see this is a void function, which means no return type, and it is in the library, or we know what std is. Std is a namespace. The swap is a function in the namespace std. And we have not talked all about these functions, but in future you will analyze this anyway. But right now we have no clue. And what you can do, of course, is here peek definition or go to definition. But when we peek this definition, you can see they use macros, they use templates, and all of this kind of stuff we have not talked. And when you watch a little bit more, they are calling even other functions in this function, which means you have to go from one function to another function, then to another function, and you have to analyze this in the future when you get better. But right now we trust them, and normally you don't trust. In future you should not trust. In future you should really analyze the swap and understand what the swap is doing, and then integrate in your code if you are sure that it cause no problems. But right now we are learning, we trust them, and the swap is really doing that what it is saying. It is swapping 2 values. You have here a value and you have here a value, and they will be swapped. But how the value is presented, we have to identify this first. So, and that we are doing now. So you can see the first value is you have to get it from this array. So we go again to this array. The pivot index is 2. We go to the array slot 2. That means here. And then we read this value. This is 4. So let me make here another color. So this 4, I will take this 4. And what I do is I will swap it with our start. So I go to the array, I take the start is 0. 0 means now I'm at slot 0. And this one, I will swap it with this. So here, let's make here a swap, and let's call this one swap. And if I'm swapping this one, I need my new copied array. Let's copy this one more time. Paste this in, because now I change values here. That means swap. And swap means here I change now this value with this value, right? That was the swap. That is doing not more, not less. Let's do this. So we have here now, here now 4. And now I have here 9. And this is finished. So here I see a sort algorithm. So when I start to swapping, that's starting to try to sort anything. But we will see if this is true. because swapping means all time you try to change the order. That's all time good. All right, let's continue. Let's see what happens next. Next is, it says here, sorting left and right parts of the pivot elements. Right and left, I don't see here right and left right now, but we have a pivot element, right? This pivot is indeed here declared pivot, and our pivot is our start. This one should be our pivot now. But here's right. Yes, we have a right side, but we have not here a left side. That can happen. That can happen. Okay, we know this, but let's see how they solve this. Let's see, that was just the description. Let's dive into this function and see. What they do is they declare outside, because we can see this I is used here inside this while loop. And when I click on this G, you can see the highlights. The G is again used inside this while loop. They declare outside variables, which called E and G, and which is just, let's write here the numbers. I is what is start, and start is what here, 0. Okay, we have 0, and G is end is 2 in this case, 2. All right, we have now the values, and now we can check this. So again, we have here a while. Again, let's check, change a little bit the style. It's okay. And here, when we know what a while loop is just a loop. And we have here a condition. Only if the condition is true, we enter this loop. And let's check this condition. This condition looks a little bit complicated. And why? Because they are not using parentheses. Look what we have here. We have here a operator, operator, operator. And when you see something like that, you have to think which operator comes first. There is a precedence list, which means, yes, like I said, which operator comes first. In this case, this part is evaluated first before this one, and this part is evaluated first before this one, and the last part is then after this one is finished, then this one will be used. And I said you can avoid this precedence list when you are using parentheses, right? Then you have not to think much. For example, in this case, I have to think really much, or even look after the precedence list of the operator to check really if this is the case, right? So this one is the case, but if you don't know the precedence list, you know what happens? It can happen that, let me show you, that this part is evaluated first, for example, and then I don't know, perhaps this part is evaluated first, and then anything else comes after this one. If strange things can happen, right? And then you have to check this part with this part, or this part with this part, and yeah. Like I said, if you see something like that, you have normally checked the precedence list, and better to avoid all the work, just use parentheses to make it sure which comes first and which comes later. All right. I hope you remember this precedence list, and then we go on. So here, let's put our values into this one. So I was 0, and let's write this one here so that's easier. 1 is less than pivot index. Our pivot index is 2, which we have get from before. Okay, this one is true, so that's good. And the other side must be true. This is a logical AND operator. AND operator means both sides must be true that you can enter this body, right? So the other side must be true too. So G is, what is G? G is 2. And 2 must greater than pivot index, and pivot index is 2. And we have here a problem. What is the problem? This is not true, right? This is false. And this AND means both sides must be true, which means we are not entering this body of the while loop, which means we can skip them and we can go to the return value, and this returns the pivot index. So, with other words, this pivot index is our return value, and when we go back to the partition where it was called here in QuickSort in P. Now I know what this P is. This P is pivot index. Let's write a comment and say P is pivot index, right? Makes a little bit more clear for us instead of all time watching this one. This is just the pivot index. All right, we have finished this one, and we can continue now. So what here, it says here sorting the left part. Sorting sounds very nice. Again, this left part in our array, left part, there is most time nothing. And we have to see. So we have again called look the function, and this function is very interesting. Why is it so interesting? Look what we have here. We have here QuickSort, and look where we are. We are in a QuickSort. What is this function called? It is called a recursion function, and careful, recursion functions are complicated to follow, right? But we will follow this one, and I will follow this probably with debug. I don't know if I can follow this here by demonstrating. I will try. If not, I use debug. Okay. All right, let's go on. So we are calling ourselves, and important is how when we call it, and so that we can track. If you have a recursion function, you need to track this. And we have already called this QuickSort already one time, right? Where was the first time? Here. So when we call this one, it's actually our second time. So that's also very important to track. Let's make here a track list. We need a track list because it's not easy, and I don't know how to make this now here. Let's make it. Let's write here just all time when we call it. Let's write QuickSort here. QuickSort. This was called here. And now I'm here, which means I call QuickSort again. Let's make this call here, just write it here, QuickSort. This one I make here intent and call it here. Right, this intent means I call the recursion. That's it. We have to track this a little bit, and you will see why this is a little bit complicated in a moment. But before we go to this recursion talk, we have to understand what this QuickSort is doing here, right? So let's go into this one, and let's see, rl start p. Let's write our argument. Start is again, you see start is still 0, all right, but this end part here, this is calculated with p now, and we know what the p is. P is our pivot index, which is this one here. This is 2, and 2 minus 1 is 1. So we have this one. This is the call what we make for our QuickSort. This call here will be included here on top again, because this is our function. All right, and we are here on the second step now here. This is very important. That's why it's a little bit complicated, because later we have to go back to this line here again. And that makes it a little bit complicated. What I mean with going back to this line, later when we finish this QuickSort here, this one, we have to go exactly to the line here and continue from here. And when we continue later from here, you will see we call this one again, which means we go back, forth, and that can irritating a lot. But yeah, we will see. All right, let's go first here. We are now in the second one, and the second one is going from start. It starts from top again, so we have to go here on top. Let's go here again and see what happens here. Just the only difference is now we have this input value here. So these two input value are changed. Let's write here the changed input value. Let's make here, this is our second call, 0 and 1. That's very important, and we are here, right? This one is not finished. We are here now. And let's continue here. Again, we are jumping to the space. We know what this is. This is just an interrupt. We have now to check just this condition. Let's make this fast. So what happens here? Start is 0, end is 1. Is this greater? So let's write here also the second step, because that was our first step which we finished. Let's write here 0 greater equal 1. This is our second step, which with these values here, and we see this is again false, right? And false means ignore this one. So that means that this is good, because now we can continue. If this is true, we can't continue. We know this. All right, let's jump into again p, and you can see p is we are calculating p again. So in this one, we are calculating p again, and this time we are calculating p with the new values. The input values is start, end, but this start, end. So we need again here this 0, 1. And then we're jumping again to P, which is here, and here we're calling also 0, 1. And then we are starting, and look what happens. All the things here are creating new. Yes, they are created, they will be new created, because I think I forgot to do this one. What happens is the partition here, when it comes back, right? I forgot to do this in the illustration. When this partition gives you here a return value, all the created variables here get destroyed, which means you can see I created this pivot, this count, this pivot index, and all this kind of stuff get destroyed. The pivot index is given here. The pivot index is assigned here before it gets destroyed, but you have to think about it. All the variables get here destroyed. Let's make this come. Because I said when you see this line, all time when you see a cross, it means get destroyed. And in this case, we finished our partition, and this was created in partition. Let's here you can see pivot was created, get destroyed, count was created, get destroyed. And let's see what I have here. The pivot index here. Yes, this pivot index here is, before it is destroyed, this one was assigned. So this pivot index is saved in P. That's why we have here P is pivot index, okay. But it's destroyed then as well. And why I destroy this all? Because now I can start this again when I here in my second QuickSort, right? So I go here back to this second QuickSort. So let's where we are here. This one called 0, 1, right? And here I started here over. Here over means I check this one. This one, that what I did was 0 is greater than this. This will be not destroyed, and we was here actually. And here I have 0, 1. 0, 1 means I go again to partition and calculate the new pivot. And let's go here. Here I have the 0, 1. And now I create all the variables again. So this was all destroyed. Here I create them again, which means I have to write them again. Okay, let's write them again. Because they get destroyed, and now I write them again. And actually I could just write here more, but I think I will write them one more time, but later, not again. Pivot is equal. Let's go here. What is the pivot here in the second round? Let's make this fast now. Or let's make it so fast as possible. Okay, again, we go here. Careful, we have to use this array now. Not this first one, because we have changed also the swap here, right? We swapped here. That's why that means we have to use this array now here. Very important. All right, let's go here. Array start is again 0 here, because we have to use this value here. We are in our second QuickSort here. So we have here array start, which is 0, 0 is 4, so my pivot is 4. All right, then we go here to count. Count is again like all time at start 0. All right, and then we have again this count, and let's see, like before, what we did before, it's probably doing the same thing here. Let's write it out what we are doing here. Eep I is the start plus 1. Start is still 0. Start is here still 0, but our end is here not 0. Our end is here 1, right? That's very important. I think I should change this end here, because yeah, this is the end from QuickSort 1. End is still 2, but QuickSort 2 end is 1. That's very important. Let's write here. Let's write here end is 1, just so that we know this at this point. And here, let's go here again. Here it says start plus 1, so start is still 0. We can see it. This is 0 and this is end. All right. 0 plus 1 is what I'm going to do now. Here. I write here 0 plus 1 is 1. And then I write here again the range 1. is I because we have calculated this, and now the endpoint is not 2, this is 1, so we make only one loop here. And when we make one loop here, we have just check if this condition is true, right? And I is 1, we go here in this I is 1, so the first slot, this is this one here. So oops, why I have here no number here. All right, here I go to this slot here. This is this one, what I do, I, and this one here, and check this value, okay, which is 1, and then I do less equal than pivot. Again, this one here, I check with the pivot, but not this pivot which I have defined here, because this one is destroyed. I have to check it with this which I created here new, right? And when I check it again, less equal, 3 is less than 4. Yes, this is true, which means I get a count plus 1, and then we have anyway only range 1 here, so that will be count only 1 time, which means my count becomes here 1. Let's make this get destroyed, and this is replaced with 1. All right, and then we can go here down again, and we are calculating our pivot index again. So the pivot index, I have to write this new because this one is added. Again, pivot index, oops, the color, make this one here. Pivot index, and we make this one, pivot index is here. Where is the pivot index here? Where is this pivot index? Here it's calculated again. Start is 0 plus count is 1 is 1, right? So start was 0, is this true, and count is indeed 1. So we have this time 1. First it was 2, not now 1. All right, and then after we have the pivot index, we are making our swap again. And what we are swapping here in this array is, you can see we go to our pivot index. Our pivot index is array, pivot index is 1 as means slot 1 here. I take this one, let's make this one a color here. Let me see if I was in the right place. Yeah, pivot index, yeah, slot 1 is this one. And I swap it with what I start. I start is 0. I swap it with this one here, which means I swap this one here. Swap. Right, this is our swap function. And I need now again here a copy of my array. Let's copy this, paste this, because this one becomes a new array. Let's put it here and see if we can. Yeah, this one, let's make this one here fast, and I have to put in now this values again, because here from this one here, and we can see what happens here. The 0 stays, and we have here 3, 4, okay, 3 and 4. And here, careful, this one looks already sorted, right? That looks very nice. But the problem here is the program is not finished. You have to be finished the program, and then you can see if the sort is really working. We don't know. We have to see what the program do till it is finished. And it is finished when we reach this point here. And now it comes the more complicated part in a moment. You will see this. Where we are. We are here where we have swapped the function, right? That was the swap function here. And now we go here again to the sort left and right part and check what happens here. Let's see here. I start. I is what here? Careful, not the first one. I is here again 0. So that one is same. But G is here 1. This is our second value. Because here we are in the second one, and here we have 0, 1. Okay. And then we have again checked this one. So we need again check this one. This was the first check. Now comes the second check. Again, I is 0 less than pivot index. The pivot index is 1. That's true again. That's good. But this one here is G is 1. Let's see. What is G again? Yes, G is 1. And 1 should be greater than pivot index 1. And this is again false. So here we have again false, which means we can't enter this body here again. all this code here is not accessible, which means we are jumping again down to this return pivot index, right? And in pivot index return, we are doing here returning the pivot index. In this case, the pivot index is 1. Here I return 1. And with this one, I jump back to this position, and this position becomes the value 1, right? And important is here, let's make here a special comment. The first round was 2. First round 2, second round 1. Okay, this is just a special comment because the first round when we did this was this one, the pivot index was 2. Here we have the pivot index 1. All right, I don't know if we need this. I just wrote it in, perhaps we need it. Okay, then we go down, and down means we have to go here to QuickSort again. And when you read QuickSort again, it is again a recursion call. We doing here again a recursion call, and that is now, you see why it gets a little bit complicated. So again, we get start is 0, this one. We get p minus 1. P was 1, second round is 1, and then comma 1 minus 1 is 0. All right, so this is the arguments. So we have now the arguments for our second round, and this one is not the second round now. We call a third round here. We had already this round, right? This was the first round. This is the second round. And now I make a third round here. This is a third round call, which means I have to call it again. Let's make here QuickSort. So I make this one QuickSort here a little bit more intended. Whoops, the color here changing. QuickSort. So here is a little bit more intended. Perhaps we can. Oh yeah. I hope you understand this intention here. When I say intended, it means if you want to go back, you have to go first to this one. If you want to go here back, you have to go to this one. And now you can see I'm here now with this call. And let's see what happens in this place here. This one looks already finished, but the code is not finished. We have to check what the code is doing, right? Okay, let's see. Let's see. We are calling ourselves again, which means we are jumping here on top again. And when we jumping on top again means here we have now the value 0, 0. So my third round is 0, 0. And now I check the case here. And when you check the case here, 0 is greater than start is 0, end is 0, and 0 is greater equal 0. Oh, that's interesting. This one here will interrupt. So here we see it will not execute the other code. This last call here will interrupt, but it is in this block here, which means this one will not execute. Let's write here interrupt. Okay, interrupt. Interrupt. All right, we go interrupt means I go back. And how you go back here means you go back to the place where this one here was called. Where was it called? It was called, let's see, here. It was called here because here I wanted to call it, right? With 0, 0, is this right? Or is this wrong? It was called here, I think, with 0, 0. This is this one. And we have an interrupt here. That means we go back to this place here, which is, this place here is here now, where we called this one free. So when I go back, I go to 2, which is this place is 2 now. And when I go back is the back where I called the free. And here I called free. So I have to continue from here. Which means, and look what happens now. That's why I said this is a little bit complicated. it is calling again QuickSort. So here I get in, interrupt, and now I call again QuickSort. Well, let's make this spacey a little bit more. Okay, this one is actually calling again. Let's put it here anywhere. Not so important. Let's keep it here. So this is not so important right now. It's important that you understand this one, because this one here is calling again QuickSort, and where we are. So we are finished with here. Let's say we are finished. We are going back to this one, and this one is calling here again QuickSort. Let's go here, but this time this p+1 here. All right. So the second one is calling QuickSort, but let's write here information that this QuickSorts are not the same QuickSorts. This is p-1. That is this version here, and this one is also the same QuickSort but p+1. Okay, here we have here this p+1 version. p+1. All right, again, and when you see this one again, it is again a QuickSort. We start here again, and let's see what happens here. So we have here p+1. p+1 means let's go here in. First of all, we have evaluate this one. So let's evaluate this one. And p+1. P was what in the second round? The second round, P was P is our pivot index 1. 1 + 1 is 2. Okay, this is 2. And my end in the second round is 1. In my second round is 1. It's a little bit really hard to follow, but it's okay. Let's see if we can do this. Because this is training, and yeah, it's just training a little bit. If you can't do it, no worry. You will probably don't need this kind of stuff. So you analyze in future a little bit better. But let's continue. Let's see if we can train our brain a little bit more and if this is right. And okay, we have this one. We have here 2. We have 1. And let's see what we have next. Where we are, QuickSort, here we are, and we call this one now with these values. These are the values which we call now. Now we are using these values here. This is QuickSort. Here on top I call myself, right? So here you can see I call myself now with 2, 1. And now let's see, I jump into it, I test this. Let's test this one here with 2, 1. So start is 2 this time, and 2 is greater, equal, and 1. Okay, this is definitely greater than 2, which means interrupt is activated, which means here I get interrupted again. So here, interrupt. Let's write here interrupt. And now, at this interrupt means you are skipping this part here. You are going back to this caller here who called this one, and we are going back to 2, which means we're going back to QuickSort, and we're going to the place where this was called, and this was called here, which means we are here at this one, and we are finished with this. When we are finished with this one, careful, look what happens. We are in QuickSort 2. We go back where this QuickSort here is called, and that was again a bad thing what I did, because this QuickSort, I should write here also a comment, that was probably QuickSort p1 call, p-1 call. This p-1, it's just indicating which QuickSort we called, and that was the call which I did in the first run, which means now you have to do this one with p+ call here in the first 2. So this one is finished, the p minus call, so I have to call this one here again. Let's do this here. Let's make here QuickSort p, and let's make this here p+1. All right, so this is this p was plan this call here, because we are here now, and I call this one here, right? And careful, when we call p+1, we have to check these values. What is p+1 in the first what is P in first recursion? The P is our pivot index, but the pivot index in our first recursion here, yeah, this P was assigned from the pivot index. I have not write P, I should write P here additionally, that was bad. That's why we can't follow this one right now, but P I should write here. Instead of P, I wrote here pivot index and destroyed this pivot index, but this pivot index was assigned to P. So here we have 2. So we have still P2, and we can see this P is then, is this 2 or is this 1 here? I'm not sure. You see, I become a little bit already not sure, because we know in the second iteration P is pivot index is 1, but we are going back, right? And now I don't know if this is now 1 or 2. I have to check this before I know this exactly, but it doesn't matter what it is, because when we take this one, it will anyway interrupt. You can see this one because here P, let's say it is 1, which is this one. It's probably not true, but let's say it is 1. Then we have here 2, right? Then we are entering this value with 2 and 1. And is in the first one, and is still 2. Was not destroyed at here. So here 2. So we have here 2, 2. And when we enter this one here, it becomes here this if statement interrupt, because 2 is equal to 2, right? It becomes interrupt. Or if it was 3, because I don't know if this is 2 or 3, if it was 3, becomes also interrupt, because 3 is greater than 2. All right, so I know exactly not what this was, but I know it was here interrupt is the interrupt is here the solution, I think. And then you can see what happens is if this is interrupted, well, this one is interrupted. Careful, this one is our third place, this is our second place. We are going, and that was P plus 1. This was this call here. We going here and going back. And when we go back, where we go back? We go back to the first one, right? We have finished now the second one, finished here. And now I go to the first one, and the first call was here. No, that first call was here, and that was P minus 1. Have I P plus 1? Yes, here. Ah, no, then it's really here. And then I go here, and then I print out the values. Here in the for loop, again, we have a for loop. Is I start with 0 in this case. And interesting is you can see they are using all time I here and I here. Why is this I and I here different? Because they have different scopes, right? This is a function int. In this scope, this I is separated from this scope, which is in this function. So don't get iterated by this one. And you should see this one as well. And let's go here again to this function. This function is just printing out our array, right? We can see it starts with 0 as long as it's less than n is defined as 3. So I less 0 less 3 and iteration and C out. And C out, you can see they are not using std because they are using this using namespace like I said before. And then we can see here RR is just accessing this array. In this case, is accessing the finished array. Actually, they are accessing this array again here, which is here, but we have changed it, right? We have all time changed the values, so it should print out this one here. And when we start this program, it is printing out this 349. But the question is now, did I make this right? Because this one was the most complicated part. Is could you follow this recursion? I think I messed up, but we can check it. How we can check this if I messed up? Let's try to count. and how we can count with the bug I said before, right? When you start this one, let's see, I don't need this one here. Let's make this little. So when you start this one here, this call, the first call here, and make here this dot here, you can click on it. And now this one is marked and we can start debug. And then we can just count what happens and see if it jumps there, 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 and back. Right, let's do this one for testing purpose. And let's start. So here it jumps here, and then we have to use this one here a little bit better, because I want not go I want go only in QuickSort, go in, and other things I will skip, because other things are just getting values. I will show you this one in a moment. But first of all, here I'm in. So when I press in, oops, not this one. When I press in, then I'm calling this one and I go first time in. All right, let's do this. And you can see I jump into the QuickSort, and this is my first call. So here, this part here, I'm in the first call here. And let's see, here I go a little bit through. You can see this one will skip because it is no interrupt. Right, that was good, because we are in this one, because if this activated, we would not go here. But we are here. This part here, I don't go in. I skip this part. Where I use the second one here, which means go over, go not in. And why I'm skipping this part is just getting me this pivot index, and it's just a number, and you can see when I skip it the first time, I should get 2 here. So let's see if this P on the bottom, you can see is right now nothing. But when I go over it, it should be P2 here. Let's do this one time. And you can see P is index indeed here too. That's good. And now you can see we are here again. QuickSort. This is my second one. Careful, I click now in. I go in. Now I am in my second one. And again, it checks here the condition. There we check it. It should be not interrupting. Yes, it's not interrupting, because it's interrupting. I would not go here. This one I skip, and this time I should get P. What is our next P pivot index? 1, right? This was 2, and here it's 1. Okay, let's see if this is true. I skip this one. I don't go in. And I just watch here P on the bottom. You can see P is indeed 1. So far, it looks good. Let's see where I messed up. And then now we are here. And when we are here, look what happens. We are here again. This is P minus 1. Here, I call this one here again. This is my first 2 and now my third, and P minus 1. And here I expect an interrupt. Let's go see if this is true. I go into this QuickSort again. Recursion. Bam. I'm in this one, and now I expect this interrupt. Let's see if this interrupt is activating now. So we can check here the numbers, but we can just go in, and you can see, check, it is in. You can see now this compiler have checked these values, and we have end and start is 0, 0. 0, 0 means we go in, and return means don't go here down, just return here. And let's see if this is interrupting, and I go in. And you can see the compiler is jumping from here down here, skipping all the other parts. And we are here. Careful, here means we are still here. We are going now back to the caller. The caller was here in QuickSort in this second QuickSort recursion call, which means we have to find now where this one was called, right? Let's see if this is true. Let's go in. And this one is jumping here. This QuickSort P minus 1. Let's see if this is really true. Is going back. But P minus 1 was already called. Is this now the start or the end? Yeah, okay. It was, I go in, it was the end. Alright, it was just irritating because it was going back, but it jumped here, but it was finishing this part here, right? And now we are here, and this one here is calling QuickSort. So when now I'm here. Again, I was here. No, that's not true. I was here. I interrupted. I go here. I go in. Now I'm on P plus 1. Now I'm here. At this point, because here I call QuickSort again in my third part, and you can see here, and I will go in this one again, and let's see, I go in. Now I'm here and I expect that I get here an interrupt. Let's see. So this one should activate here again. And we can see it gets indeed activated. It was Q1 indeed. I saw the values, that was too fast, but it was Q1. That's why it gets activated here. And we jump here again to the last part. All this part is skipped because this one is a return. But we are still here at this part. And when I go now here, where I am now, here I was interrupt. It means I go back to 2 and I'm finished now with p+1. p+1 is this one, but this one looks strange, but it is finished. When I go in, you can see this is this symbol in. It is not going in, it is finished with this line. So this one is okay, which means we have finished this block here, which means I finished. That's not true. I finished the second block here actually, because I went here, go back, I went here, go back. Now, the second quick, this one here, is finished. When this one is finished, I go back to the first, which called p-1, which means this one to this caller. I go back here. Let's see if this is true, because I thought I messed up anyhow, but it looks like I'm here till now. Perhaps I messed here up. Let's see. This one was okay, and this one was the place where I go back. And here you can see what I expect is that this one should not go in now, should go here. Let's see. Yes, that was expected. And you can see the first one here is calling the second one, and the second p+1. You can see this is second. This is second, so intention here, right? The intent I use here. So this one is now indeed this one, and this one goes again in this one, right? We can see this, yes, because this one has we have check. And let's see what happens here. Here you can see I go in and I expect that it's interrupt again. Let's see the values. You can see we have here 3, 2. Right, let's see, that is 3, 2. So, and the values which I calculated was anyhow total wrong. So I messed up with the values here. So I messed up anywhere with values, because I have here values 3, 2. But that's not very important. That's not very important now. I have wrong values. Anyhow, I made something somewhere, something wrong. All right. But the compiler says I have here 3 and 2. Let's see what the problem here is. Well, let me see why we have here 3, 2, by the way. So we are here, we are p+1. p+1. 2 I understand, but why 3? Because we made p+1, right? And p was that. Must be 2. P must be pivot index 2, and 2 + 1 is 3, and 3 and end was anyway 2. All right. I messed anywhere up, but I know why it's okay. And let's see. And this one is going in. Interrupt. So important is that you understand this recursion a little bit, training this one, not my messed up numbers. And here you can see we have here QuickSort is which we are p1 interrupt, and after this one I go back. Let's see where I go. It go back to the first one. So first one is here, and now I'm finished with first one here. Should be finished now here. You can see this. I'm finishing now my first one. After this one, I should jump here to this place and continue to for loop. So let's see if this is true. Yes, it's jumping here. This one is finished. So let's see what happens next. Jumping here to the for loop. Okay. And for loop means just you are printing out here the array. So we can go skip this. I made skip, I thought. And we can see the values here are 3. I still not skipped that. I thought I skipped this. Yeah, I go out of this one, then I skip this. And after this one, you can see 3, 4, 9. All right, so you can see I messed up here. Some numbers are anywhere, but it was this P probably, that was pivot. Anyway, I messed up the one number, but in general we analyzed anyhow, it's okay. All right. And the final question, and the most important question, did we understand now QuickSort? Actually, no. that is crazy, but we understand not QuickSort right now. And the problem is here, we have to analyze this a little bit more. And why? Let's go back here, and this partition here, actually, we have never used this block here, right? We have never used that. And the reason for that, because we never used it, because we met not this condition. So we can't understand this code in let's say we have understand only a part of this code here. And we have only understand it is doing a sorting so far that the pivot is anyhow all time on the left, right? So that we see the pivot here was here, then here, and then it's trying to sort it anyhow. But I don't saw left and right sorting in our case. We all time had this one here, right? We've started with this one, then we swap this one, then we get this one becomes our pivot, and then we swap this one, and then this was already our last value, and we need more information, and especially this code condition was never met in our example. So with other words, we need more examples to understand this code. We have here no chance to understand it with this little example which I made. And yeah, that is a little bit hard work, but I think that's enough for us starters that we can say, okay, that's enough train. And this solution is actually that we have no solution. That is our solution. Too bad, yes, because we need just more data, just more condition checking. We have never activated this one here, so we don't know what this one is doing when we have when we have here a array who is activating this condition. So we can say, like I said, we don't know what the pivot what a QuickSort is. The only thing what we know here is it is not quick. Do you think this is quick? Here, what with this, what we analyzed here? That looks really a lot of recursions here. It looks not quick. At least it looks not quick. And the reason why it looks not very effective is probably yeah, like I said, we have never activated this block here. We don't know. So this is my solution. We don't know because we need a little bit more data to understand this one. And with other words, we have now to trust this side that this is a QuickSort, because if you don't trust, you have to find now examples where the other code is activated and really used, and then to see how this is interacting in this code. But we skip this part. And this was anyway more an exercise where you train to use all the keywords to follow this recursion a little bit and to see how this was work. But I want that you still learn QuickSort, so you should read this in Wikipedia perhaps, or here, if this is right. Read here the description, but read also Wikipedia, because most time Wikipedia is checked that this Wikipedia is right. The problem in Wikipedia is they don't put code there. They put there only pseudocode, but they explain it at least. In Wikipedia you will find an explanation, which is most time accurate enough for a starter to understand what a QuickSort is. All right, this is our next job. We read just the explanation because we could not figure out through code. At least I could not. Perhaps you could. Perhaps you made a little bit more work than me and spent and tried to figure out how this works. But I could not really figure out when I say, if I say I just use this code is not enough to figure it out, but I would say, because we need a little bit more checks here. Yeah, and with that said, I stop this one. And in the next video, I want to go back to our exercise, and you can see we have to implement here a sort algorithm, and we learned now this bubble sort, this quick sort, and yeah, you can try. And if you learned a little bit more sort algorithms, try to implement this one in your linked list. We are going back to this one. We created already this function here, and then try to implement this one. And then we will continue with other things here, the other ones. All right. Okay. See you in the next, and I hope it was not too complicated. But the important part is that you do all the stuff what you see here, what I did on your own, because then you train. Just watching and understanding will not help, because the train effect is here the most important part for you actually. That you did it and that your brain is trying to understand this, and the best way is just by doing it yourself. And perhaps you do it better than me, because you see I made already a mistake because I was made it fast and it was not perfect, but it worked anyhow. All right, with that said, if you have any questions, any comments, write it in the comment sections like all time, and see you in the next video. Bye, good luck, and like all time, have fun and never give up.